In this video, I will explain the limits at infinity. Remember here, in the coordinate plane, x and y, okay, see here, we have the graph, the curved graph. See this one, we say minus infinity, here infinity, and we have here infinity, here minus infinity. Remember here, we close to 0, here also close to 0. We saw this is the asymptotes. The asymptotes, we have two types, we have a vertical and horizontal. Okay, before I will explain the asymptotes, I will write the definition of the limit. We have limit f of x when x approaches to infinity. We have L. L here may be number, maybe 0, maybe infinity, positive or negative. In this part, I will explain the asymptotes. We have two types. We have horizontal and vertical. See here in the coordinate plane. Here we have x. And here we have y. This is the graph. Okay, when I say horizontal, we want to draw some things like this. This is the horizontal. Okay, how can you solve the questions for the limit? We'll divide it by the highest power of variable. This one way, or we will use it the second way, derivative. This is we have, how can you find it? The horizontal asymptotes. 1/4 the highest power, we'll divide it by highest power, then we'll find the horizontal asymptote, or we will derive their functions. Okay, in the horizontal, see here the vertical now. Here we have x and here we have y. I will draw the figure for you like this. Okay, this is the vertical, see. Okay, the vertical here, we will take the part of the numerator and denominator. We take the part of denominator equal 0. Example, if I ask you limit, you want to find the x minus 1 over x plus 2 when x approaches to infinity. Okay, you want to find the vertical asymptotes. I take this part equal 0. Then we have what? X equal negative 2. Okay, this is the vertical. This is, we say, vertical asymptotes. Okay. In this part, we will solve many questions about the limit of x approach to infinity. We will start with the graph, then we have the questions to find the limit. Okay. In the limit, here we have minus infinity. Here we have positive infinity, here we have positive infinity, here minus infinity. Okay, we ask you limit of f of x when x approaches to infinity. We go to x, infinity here, see? This is infinity, okay? We will go to positive, this is the positive. See the graph? Which number here? We have part A, negative 2. This is, we say, horizontal asymptotes. Okay. Part B, we have a limit of x approach to negative infinity. Negative infinity here, see? We will see this is the line, we go to negatives. We will draw the horizontal line. What is the number? We have 2. Also, this is the horizontal asymptote. Okay. Okay. The second part, we have part C, limit x approach to 1. Where is x approach to 1? Here. We will draw the vertical line. Okay. This will go to positive infinity. We say positive infinity, and this is the vertical asymptote. Okay. D will go to x3. Then I'll draw the vertical line. We say we'll go to minus infinity. Also, this is the vertical asymptote. Okay. This is in this questions we want to find the limit. Remember, here when we ask you about find the limit, that we have horizontal asymptotes. Okay. The horizontal asymptotes, we have two ways. One for the highest power or derive. I put it the answer for both, and we check that we have both is true. Okay. Now here the highest power for this one, x to power 1. That meaning x. Okay. We will derive it. We will divide it all the term by x. Okay. We will write it limit x approach to infinity. We have 3x divided by x minus 2 divided by x over 2x divided by x plus 1 over x. Remember, here we have notes. Note limit 1 over x when x approach to infinity, always what we have 0. Why? Because 1 over infinity we have 0, because the graph for the 1 over x like this. Okay, this is that meaning this part 0, this part 0. Okay, we will simplify x with x will go. What we have 3, x divided by x we have 1. What we have 2. The answer for this one 3 over 2. Okay, this is the answer. This is the first way. The second way, we must have the same. We will derive 3x. The derive for 3x we have 3. Derive for constant 0. Derive for 2x we have 2. Okay, derive for 1 constant. What is the answer? 3 over 2. This is the second way. The second way, I will write it here, derivative. Okay, derivative. Here for the first part, divided, we'll divide. Okay, we'll go to the second example. Okay, here we have a limit when x approaches to infinity. What is the highest power? Some students will say for me x squared. But remember, here we have a note in the right. If I write it radical x squared, what equal? That here 2. 2 divided by 2, what we have? 1. That we have x. Okay. Inside the brackets, we have x squared, but outside the radical, what you have? X. If you have x to power 6, this is what I will do it. We say 6 divided by 2 outside the brackets, what you have? 3. Okay, if you have radical x to power 8, now 8 divided by 2, 4, we can say x to power 4. Inside the radical x squared, outside we have x. Now inside I divided by what? X squared. Outside I divided what? This is 4. This is outside. This is inside the radical. That when I say out and in inside the radical, all the parts I will do it limit when x approach to infinity, here like this. I will make the radical here x divided by x squared plus 3x squared divided by x squared. All this is inside the radical. I will make it more big for you. And here we have 4x divided by x minus 1 over x. See here, this is 0. This is x squared divided by x squared. We have 1, we have 3. Here what we have, I will write this note because some students will ask me, x over x squared. How can I simplify it? We have division, we subtract the power. Here 1. We say 1 over x. Because 2 minus 1 we have 1. Okay, that meaning this one we have 1 over x. 1 over x, limit 1 over x, what equal? 0. Okay, this part also 0. Okay, now what I have inside, we have only 3. We say radical 3 over 4. The answer. Okay, you can derive, but the derivations for this one is the chain rule. Still in chapter 3 we will explain it. Okay, here we have the limit 1 minus x to power x over 1 plus 2ex. Okay, how can you find this one? In my idea, this one uses the derivative. We can divide it by the highest powers. We have x divided by x, it's okay. But in my idea, derivative this one, x to power infinity, 1 derivative for 1 0. Okay, 0 minus this one ex. We have the derivative, we have ex. Here we have 0 plus 2 ex, the derivative. Okay, now what we have, limit x approach to the infinity minus ex over 2 e to power of x. Okay, now here e to power of x, this is, and this we have like x over x, we have 1. Then what is the answer? Minus 1 over 2.